things that are non-mutually exclusive events. Non-mutually exclusive events are things that have this overlap. We have items that are mutually exclusive that would be more like two circles that have no overlap when we look at Venn diagrams. Now, non-mutually exclusive events are where we have these overlaps. And so when we look at probability of A and B, two events happening, we're looking at where they intersect. And so that's this part right here. This part right here is the probability of A and B happening. They both have to occur. When we look at the union, probability of A union B, that's where we want it to be in A, or we want it to be in B, or it could be in both. So a union, an or, means it can be over here in A, or it could be in B, or it could be in both. So in other words, just anywhere either one of these are. Again, an intersection, an and, means I gotta be in both of these places, type of thing. We have to be careful about the or, the union. When we look at this, we want to make sure that we don't count things twice, because things inside of here are inside of this circle and they're here, but they're inside the circle and they're in here, type of thing. And so when things are not mutually exclusive and we want a union, we have to look at the probability of event A happening plus the probability of event B happening minus the probability of their intersection. And the reason why is because some of those people may have been counted here, and then they were counted again here, and so they were actually counted twice. And let me do a little bit of a diagram here. So let's say that I counted probability of A, which is all of this circle. Okay? Everything in here. Then I go through and I count everything in B. Well, if you notice, I actually have both colors in this part right here. So these, whatever's inside here, has actually been counted twice. That's why I have to remember to subtract out those overlapping areas. So let's look at this example where we have 30 students in a shop class. 18 build a birdhouse, 8 build mailboxes, and 3 build both. When you're looking at Venn diagrams, you always start with the innermost part and fill it in first. So 3 are going to build both a birdhouse and a mailbox. Then what you're going to do is you're going to look at, okay, so we have the birdhouse and we have a mailbox. So 8 build mailboxes. But I have 3 of them already here, so I need to subtract out the 3. So 8 minus 3 leaves me with 5 that strictly built a mailbox. Then I have 18 birdhouses, but I subtract out the 3, leaving me with 15 total that built just birdhouses. So I have to remember to subtract out that overlap here. When I'm drawing my Venn diagram. because whenever I do birdhouse or mailbox, I would look at the probability of building a birdhouse plus the probability of a mailbox minus the probability of both. So birdhouses would be 18 out of our total of 30. Mailboxes would be 8 out of 30. So 18 and 8 would give us 26. But then we have to subtract out our 3 out of 30. So that would give me 23 out of 30. And if you add these three numbers up, 15 plus 5 is 20, plus a 3 would give me 23 out of 30. And then the probability that we build a birdhouse and a mailbox, well, that's just the intersection. So that would just be 3 out of 30. Or, if you simplify that, that's 1 out of 10. So you do have to be careful when you're talking about the non-mutually exclusive type of events. Let's look at a deck of cards. Some of us know our deck of cards, some of us do not. I will say that we have these items here that are going to be considered our face cards. There's a total of 52 cards. We have the clubs, the spades, the hearts, and the diamonds. Okay, for those of you that are not familiar with your deck of cards. So the probability of selecting a jack, so that would be these guys right here. So there are 4 out of 52 cards here. We have an or. And then we're going to select black cards, which are all of these. And so half of 52 is 26. And you'll notice that I circled these two both times. That is your overlap. That is your intersection type of thing. Because these two guys got counted twice. So we need to subtract those out. So that'll give me 28 out of 52 total, which I can simplify that into 7 out of 13. Now I'm going to erase that so I can see it a little bit better. I want a 5, which is right here. So that's going to be 4 out of 52. Or a heart, which are these guys. So that's going to be 13 out of 52. And you'll notice I circled 1 in both times. So that I'm going to subtract that 1. So that will give me 4 plus 13 is 17, minus 1 would give me 16 out of 52, which would actually give me 4 out of 13. And then I want to select a face card or a red card. So my face cards are here. There's 12. And my red cards are here, which again are 13. And you'll notice that I overlap 6. So I have 12 out of 52 plus 26 out of 52 minus 6 out of 52, which will give us 32 out of 52, which simplifies into 8 over 13. And the last one is a queen and a club. Wherever you have the and is strictly where they intersect. So you look at the club, which is here, and then you look at the queen, which is here, and it's that overlap. So it's actually just 1 out of 52. Overlap, the and, whenever you're talking about two characteristics of the same thing, is strictly where it intersects.